Hello, in this short lecture I will give you a proof to the Pythagorean theorem. The Pythagorean theorem is actually related to a right triangle. As you can see here, right triangle is a triangle in which one of its angles is 90 degrees, like this angle is 90 degrees, and the Pythagorean theorem actually says that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in mathematical notation it says that c squared is equals to a squared plus b squared. In order to prove the Pythagorean theorem, we actually made a copy of this right triangle. We actually made a copy of it here, and we make the copy by actually by creating line A along the side B, by creating the side A on the same line of side B, and then we actually made a perpendicular to A, and the size of the perpendicular is the size of B. So the angle between side B and side A is 90 degrees. So actually we created another triangle in the left side that is actually coincides to the right triangle, and I will explain you why those two triangles coincides to each other. First of all, they have two sides that equal to each other. Side A in the right triangle equals to side A in the left triangle, and side B in the right triangle is equal to side B in the left triangle. Then the angle between side A and side B is equal in both triangles and is actually 90 degrees. The angle between A and B in the right triangle is 90 degrees, and so is the angle between sides A and B in the left triangle is also 90 degrees. So we actually in this way proved that the right triangle coincides with the left triangle because they have two sides that equals to each other, A equal to A and B equal to B, and also the angle between those two sides is also equal to each other. The angle in the right triangle is 90 degrees, and also the angle in the left triangle is 90 degrees. And in this way we actually proved that the right triangle coincides to the left triangle because they have two sides, and also the triangle between those two sides that equals as I already said, side A in the right triangle is equal to side A in the left triangle, side B in the right triangle is equal to side B in the left triangle, and the angle between side A and side B in the right triangle is 90 degrees, and so is the angle between side A and side B in the left triangle. It is also 90 degrees. Therefore, the right triangle is equal to coincides with the left triangle. And for this reason, this side is side C, because it is actually the corresponding sides in coincides triangles. Okay, and if we label the angle between side A and side C as alpha, so the angle between side A and side C in the left triangle will be also alpha. As you already know, the sum of the angles in every triangle is equals to 180 degrees. So if we label the angle between side B and side C in the right triangle as x because it is an angle that we don't know how much is this angle, so we will label it as x. How much degrees is the angle between line B and line C in the right triangle, so we will label it as x. And as I've already told you, the sum of the angles in the right triangle equals to 180 degrees. So alpha plus 90 degrees plus x equals to 100 degrees. We can write it here. Alpha plus 90 degrees plus x equals to 180 degrees. Okay, so you can see it here. Alpha plus 90 degrees plus x equals to 180 degrees. It is true for every triangle that the sum of its angles always equals to 180 degrees. So we can subtract 90 degrees from both sides of the equation, and then we get that alpha plus x equals to 90 degrees. As we subtracted 90 degrees from both sides of this equation, we get that alpha plus x equals to 90 degrees, and alpha and the x equals to 90 degrees minus alpha. X equals to 90 degrees minus alpha. So we can write here x equals to 90 degrees minus alpha. As you already know, the sum of the angles in every straight line in one side is 180 degrees. For example, the sum of the angles in the upper side of this straight line is equals to 180 degrees, and so is the sum of the angles in the bottom side. In total, the sum of the angles in a straight line is 680 degrees. And if we relate only to the upper side, the sum of the angles in the straight line, this straight line is 180 degrees. And if we label the angle between side C of the right angle to side C in the left angle, if we label the angle as y, then we can say that x plus y plus alpha equals to 180 degrees. X plus y plus alpha equals to 180 degrees, according to the rule that the sum of the angles in the upper side or in the bottom side of a straight line is equals to 180 degrees. But we know that x equals to 90 minus alpha, so we can substitute x with 90 degrees minus alpha plus y plus alpha equals 180 degrees. We substituted x by 90 minus alpha, 90 degrees minus alpha. So here we have minus alpha plus alpha is equal to 0. So we can eliminate alpha from the equation, and we will get that (90 degrees) plus y equals to 180 degrees. Okay. Minus alpha plus alpha equals to 0. So we left with 90 plus y equals to 180 degrees. We will deduct 90 degrees from both sides of the equation. And at last we will get that y equals to 90 degrees. So this angle is a right angle, equals to 90 degrees. So the middle triangle is a right triangle. As you can see here, we deducted 90 degrees from both sides of the equation, and we got that y equals to 90 degrees. You can write here that y equals to 90 degrees. Now, as you can see in the picture, we have here a trapeze, and we actually will calculate the area of this trapeze in two ways, and then we will compare the results. Of course, the first result must be equal to the second result, and in this way we will prove the Pythagorean theorem. So the first way to calculate the area of this trapeze is actually to say that the area we label the area as S, the area of the trapeze as S, equals to the sum of the sides that parallel to each other. Side A is parallel to side B, therefore it is A plus B times the height of this trapeze, and the height is also A plus B. So it is actually A plus B times A plus B, and we will divide all by 2. So the first way to calculate the area of this trapeze, we can say that it is the sum of the parallel sides, that is A plus B, times the height of this trapeze, that is also A plus B, divided by 2. Okay, and the second way that we can calculate the area of this trapeze is actually to say that the area of the trapeze is the sum of the areas of the three triangle, the left triangle plus the middle triangle plus the area of the left triangle. So the areas of the three triangles that are contained by the trapeze equals to the area of this trapeze. So we will calculate the area of the right triangle. The area of the triangle is its base times the height to this base divided by 2. So the base of the right triangle is actually B, the height to this base is A, so it is A times B divided by 2. This is the area of the right triangle plus the area of the middle triangle. Here is the base of the triangle, that is C, times the height to this base, that is also C, divided by 2. So it is C times C divided by 2, plus the area of the left triangle, that is actually A, the base that is the base of the triangle, that is A, times the height to the base, that is B, divided by 2. So it is also A times B divided by 2. So in total we got that the area of the trapeze, when we calculate it in the second way, is the sum of the areas of the three triangles that are contained by this trapeze, and actually the area of the right trapeze the area of the right triangle, that is equals to A times B divided by 2, plus the area of the middle triangle, that is equals to C times C divided by 2, and the area of the left triangle, that is equals to A times B divided by 2. As I already told you, expression 1 is equals to expression 2, because we are dealing with the trapeze that we calculated its area in two different ways. So we can actually compare expression 1 to expression 2, or we can say that expression 1 is equal to expression 2. So we will do this equation now. The area of the trapeze in the first calculation was A plus B times A plus B divided by 2, and it is equal to the area of the same trapeze as we calculated it in the second way, that is actually the sum of the areas of the three triangles, the right triangle, the middle triangle, and the left triangle. So it is equal to A times B divided by 2, that is the area of the right triangle, plus the area of the middle triangle, that is C times C divided by 2, plus the area of the left triangle, that equals to A times B divided by 2. Okay. Expression 1 equals to expression 2. The area of the trapeze in the first calculation equals to the area of the trapeze in the second calculation. So here we can multiply the equation by 2. Then we will get that A plus B times A plus B equals to A times B plus C squared plus 8 times B, 8 times, so we multiplied the two sides of the equation by 2. Now we know that A times B plus A times B equals to 2AB. Plus C squared. Okay, A times B plus A times B equals to 2AB plus C squared. Here it is the same. Now we will open the brackets in the left side of the equation. So A times A is A squared, A times B is AB, B times A is BA, and B times B is B squared, is equals to 2AB plus C squared. And AB plus BA is 2BA. or 2AB, it is the same. So AB plus BA is 2AB. We got A square plus 2AB plus B square equals to 2AB plus C square. Now we will deduct 2AB from two sides of the equation. And the last expression that we got is actually exactly what we desired. After we deducted 2AB from both sides of the equation, we got that A square plus B square equals to C square. Or we can say that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Then that is exactly what we wanted to prove. Okay, so we can summarize and say that we actually had a right triangle, and we wanted to prove that A square plus B square equals to C square. And we did a copy of the right triangle here. We calculated those angles, and then we got a trapeze, and we calculated the area of the trapeze in two ways, and then we compared the two results that actually of course equals to each other, and in this way we got the last expression that says that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, I hope that you enjoyed from the lecture and you understood it. All the best. Thank you very much.